Hi, I'm Konrad. I'm one of the co-founders of Rhinestone, and we're building infrastructure for modular account abstraction. So we've been building for almost a year now, and we got started at ETH Denver last year. Today, I'll be talking about modular account abstraction, what it is, what the current landscape is like, and where it's going. So there are a few technical challenges for building ERC-437 accounts today. In a previous video, you can learn more about how ERC-437 works and how accounts are built today. But for the purpose of kind of modular account abstraction, the main challenges are, one, accounts being built in a monolithic way. That means that accounts have a certain set of features that they come with. If a developer wants to add new features, they have to build a new account or fork an existing account and add those features, auditing it and duplicating a lot of the engineering work. And another challenge for building ERC-437 accounts today is that it's really hard for developers to add features to an account when they're not the account builder. So for example, say that I want to build a dApp and I want to enable a certain kind of validation scheme, or I want to trigger certain automations on the account. I can't do this without building the account myself. So the general idea of modular smart accounts is that instead of having a monolithic smart contract account that holds both the core logic and all the features, you have a vanilla kernel that holds kind of the core logic of the ERC-437 account, and then has different modules depending on different features. So I'll go into kind of what those features are later down the line, but that's the general idea. And the main upsides of that are that instead of kind of having to maintain this, on the one hand, big code base with a lot of like complex features and a lot of kind of like dependencies that are going on, and on the other hand, having to continuously have to maintain it and add new features, as for example, you want to allow support for passkeys, for validation, or for automations, for like executions. You instead have, like I said, this core account, and then kind of like you can build self kind of encompassed feature modules and add those later on, and you don't have to re-audit the account kind of time and time again. So the modular account abstraction space consists of a few different components. So these ecosystem components are, first of all, the account, the modules, the registry, the UI, and developer tooling. So going through these in turn. So the first of these are the modular accounts. Obviously, these are the core technical pieces. A modular account consists of kind of the base features. So those base features will basically allow it to be ERC-437 compatible. So it would allow the entry point to call the account with validate user op. After the validate user op has returned true, the entry point can then call into the account to execute. And the idea is that during both execution and validation phase, the account can use different modules to perform certain logic. So the second ecosystem component are these modules. I'll go into kind of the specific module types and examples in a second, but the rough overview is that any developer can build a self-encompassed module, and those can be arbitrarily short. So they can be very short smart contracts that are 30, 50, 60 lines of code, arbitrarily complex, that encompass like a lot more logic. Then the third ecosystem component is what we call the registry or registries. So these components are on-chain contracts that allow a smart contract account to get guarantees that a module that they want to install or that they want to use is actually secure. And the reason why that is needed is because a contract that's on-chain can't actually know whether something that they're interacting with is secure or not. So we need kind of these on-chain assertions in some way, shape, or form. And there's kind of like different approaches to doing this, but we need some sort of on-chain assertions that guarantee to the account that a module that they want to interact with is secure. Then the fourth ecosystem component are UI, or generally UIs. So right now, if you look at any, on the one hand, wallet, on the other hand, dApp, these are kind of static UIs. So for example, if you look at the wallet, whether that's an EOA or a smart contract wallet today, you will see kind of like the core features. And you can't really customize those features. You can't really add new features. You can't really replace or remove. So one thing that we think will happen over kind of like as modular smart contract accounts gain adoption is that these UIs will also become more modular. So that, for example, when you add a feature into your account, you can also add a way to interact with that feature into the wallet, so into the user interface. And then the fifth and final component of the modular account abstraction space are developer tools. So these developer tools allow obviously developers to build different components of this ecosystem, most importantly, modules. One of the main advantages of modular account abstraction is that account builders can build kind of this kernel of account that is very vanilla, and then module builders can build modules that are features. And the account builders and the module builders don't actually have to be the same person. Right now, with monolithic accounts, they are, because the account builders build all the features, but in the future, they won't be. So these dev tools are mostly around allowing module builders to easily build those modules and also distribute them into accounts. Modular accounts have actually been around for quite a while. The earliest has been the Safe, formerly the Gnosis Safe, who's been modular since 2017. But especially kind of at the start of 2023, modular account abstraction started to really take off. And there started to be a lot of debate around the different approaches to building these accounts. So the two main approaches are, on the one hand, you have a callback-based architecture, which is what the Safe has been doing. And then on the other hand, you have a kind of a delegate call or diamond-based approach. So for those unfamiliar, diamond proxies are also known as ERC 2535, are a way of building proxy contracts where you have one kind of stateful contract and multiple implementation contracts, rather than kind of more generic Solidity proxies where you have one stateful contract and one implementation contract. So the difference in the approaches there is, on the one hand, you have kind of these callback approaches where you have an account that calls out to a module, and then a module calls back into the account. Whereas on the other hand, you have these delegate call-based approaches where an account delegate calls to a module and sort of gets that code and executes that code in the context of the account. So since kind of the start of 2023, there's been a lot of debate about what are the upsides of each of these. Delegate call-based approaches can potentially be cheaper, but also more difficult to handle from a security perspective. So I think realistically, kind of where we see the ecosystem today is that the existing accounts and standards are converging to compromise or a middle point. We have some aspects of delegate call-based approaches, but also some aspects of callback approaches. So modules are self-encompassed feature components. So they're smart contracts themselves, and they enrich the experience of a smart account. A modular smart account is kind of this vanilla kernel that uses those modules for the most important features. So I think one thing that would be helpful at this point is breaking down modules into the specific module types as we see them today. So as most people in the space that are building in modular account abstraction see it today, there are 4 different module types. So the first one are validators, the second one are executors, the third ones are hooks, and the fourth ones are fallback managers or fallback handlers. So I'll go through each of those in turn. Validator modules are used during the validation phase of ERC 437, and kind of the exact flow there is that the entry point calls the account, specifically the validate user op function on the account, and then the account will call into a module, into a validator specifically. And that validator will perform all the signature verification and actually check whether that signature is correct or incorrect and whether to execute a certain user operation. So this is in contrast with kind of the account doing the validation logic themselves, because this way you can switch out the validation logic, either for consecutive user operations or kind of down the line, a user can switch out how they interact with their account. And the second module type are executors. So executors call back into the account and can queue executions. So one example for this, a user wants to perform executions that are dependent on each other. So for example, you want to perform an execution where the account performs step 1, then gets a return value, and based on that return value, performs step 2. So that's one example of an executor, and I'll go into more examples in a second. So to recap here, like the point of executors is to modify the execution behavior of accounts. So then the third module type are what we call hooks. And hooks, basically, as the name suggests, hook into the execution. So they will be called before and after every execution. And they allow modifying the behavior of the account. So for example, you could check that an invariant is true before an execution and still holds after an execution. Or you could add an execution before every other execution. So for example, you could allow an account to do a swap, and in the hook, so actually before that execution, you make sure that they actually have an approval set. And also kind of the inverse of this, after the execution, you can make sure that all of the approvals are removed. And then the final module type are what we call fallback handlers. And this is related to the Solidity concept of fallback, which is basically this catch-all function that is called when no other function selector in the contract is kind of matched. So if you try to call a contract with a function selector that's not present in the contract, then the fallback function will be called. So for smart accounts, kind of this fallback function will then route to a fallback handler. And this can be, an account can have multiple handlers installed, or it can have one installed. But this fallback handler would then kind of perform logic. And the main kind of purpose of fallback handlers is to future-proof an account. So for example, you have an account today, and then a standard, for example, a token standard requires a certain function to be present on an account. You can just install that through a function handler without having to modify the base account and redeploy it. So to give some more concrete examples for each module type, I'll go through them in turn again. So for validators, one very obvious example is just ECDSA recovery. So using an EOA to interact with a smart account. But then you can have more complex signature logic like WebAuthn or passkeys, which is talked about a lot today, which basically use a different elliptic curve to what EOAs do, and they're present in most hardware today, such as like phones and laptops. But you can also have more complex validation logic, such as multi-signature schemes, even multi-signature schemes where each signature has a different kind of elliptic curve or a different kind of algorithm that is used. Then for executors, the second module type, some examples are around automations. So for example, you could have some dollar cost averaging, where basically a user can set up an interval and kind of like two tokens that they want to swap between. And then they trust a relayer or a network of relayers that's decentralized to kind of trigger these automations. And you can also have kind of more complex executors. And you can also have more complex executors, such as a portfolio management executor that actually takes care of your entire portfolio. And you input kind of certain goals or invariants that you want to hold. And then the manager kind of either some algorithm or some AI-based kind of like model actually rebalances your portfolio. It kind of responds to trends in the market and so on. And it basically automates your entire portfolio management. So the UI of wallets right now is static. That means that when you install a wallet, you have the features that you get and you don't have a say in customizing this. And this makes sense for EOAs because the behavior of EOAs can't change. And it also makes sense for static smart contract accounts because their behavior cannot change. But with this move to modular smart contract accounts, the behavior of the actual smart accounts on-chain can actually change. So you can have different validation logic, different kind of execution behavior like I talked about earlier. But this also requires a step change in how these wallet UIs work today. And this is all kind of very much up in the air right now. Like we're very early in general to modular account abstraction, even earlier to the UI components and the front-end components of that. So there are some different ways in which this could play out. So we'll talk through two different ways in which I think that this can play out. The first way is that wallets, so the UIs, the interfaces that users interact with, become modular as well. On the very easiest, you can imagine kind of a UI that allows users to drag and drop different components. So for example, you can press add to a new component, like an executor that performs a certain action, and then it's dragged into the UI and you can drag it around and kind of like customize how it works and how it looks. That's one way. Obviously, there are significant challenges around that, especially around the security aspect of it and the distribution aspect of it. For example, how does a module builder that builds a module on-chain, so the smart contract, how do they also build the front-end component of that module and then integrate it into the wallet, especially in a secure way? So that's one way I think it could play out. And there's some research going on there, I think, that is very interesting for developers to get involved in. And then another way that it could play out is that wallets actually become much more ephemeral in that people don't really have a home wallet anymore. You don't, for example, have MetaMask or Rainbow that you go to, but instead your wallet just becomes this ephemeral thing similar to kind of embedded wallets or embedded signers as they're called today, where you go to different specific applications for different purposes. So you might go to one application and log in with your smart account to view your DeFi portfolio and your DeFi kind of positions. You might go to another one to view your NFTs and trade your NFTs and so on, depending on the different use cases. One of the important kind of like areas of research and development there is around connecting your account when that becomes like more ephemeral to these different applications. One approach there is around like single sign-ons, and there's an ERC 7555 around this, which I encourage developers to check out and get involved in as well. The final ecosystem component that I mentioned earlier is developer tooling. And developer tooling in this context mostly means allowing developers to easily build and distribute modules. The general modular account abstraction ecosystem is pretty young. Like most of the activity has happened since like the start of 2023. So the dev tooling is also very nascent. There are some kind of initial tools that are out there. One of them is called the Module Kit, which is actually built by us and is open source and has had contributions from different members of the community that allows developers to easily build modules for pretty much all the modular smart contract accounts that exist today. So that includes the safe, the economy account, the zero dev kernel, and the ERC 7579 reference implementation. This specific tool, the Module Kit, basically allows the developer to build a module in a way that's compatible with all of these accounts and then also very easily test it and distribute it, so essentially deploy it on-chain. For other aspects of the module developer journey, there are other tools. One example of that is permissionless.js, which is a front-end library that you can use to integrate, in general, smart accounts, but also modular smart contract accounts and also modules into a front end. So that's an example of where an application developer, such as someone building a dApp or is building a wallet, can integrate these modules and use them from the context of within a front end. So contributing to the modular account abstraction ecosystem is actually very broad. There's a lot of different areas where people can get involved, and the ecosystem is still very early. So it's very easy to kind of dive in, upskill a lot, and then contribute meaningfully to the ecosystem. So on a code level, there are certain areas where a developer can get involved. One of them is definitely building modules. So building different kind of like modular components that I talked about earlier, validators, executors, and so on. A developer can use the different tools that I talked about earlier to do that. Another example, which I think is less entry level for developers, is obviously building an account. I think the main value add there is kind of the learning experience for a developer. There are already different kind of modular accounts out there with different trade-offs, and kind of that ecosystem is not saturated, but I think there's a lot of like development happening there. So I think the main objective there for a developer could be the learning experience of kind of reasoning and kind of like starting to almost rediscover modular accounts from first principles, even if this is just kind of like an object of discovery essentially and not actually distributing the account. So I think that is definitely like very helpful and has been helpful to me in the past. And then other aspects of getting involved on the code level are building applications that use modules. So for example, building applications that use session keys or passkey validators or executors is definitely like a way to get involved and meaningfully contribute to the ecosystem. So apart from contributing on a code level and on a development level, people can also get involved on a higher level. So for example, in terms of research, in terms of product thinking, in terms of a wide array of other activities. Some examples here include product thinking around kind of what is possible with modules, or what specifically, what I think is very interesting is what product experiences aren't possible today or will be possible in a seamless way using modules. So that's definitely one way that people can get involved, even people that are non-technical. And another way is joining the communities. So for example, the Telegram group chats and reading up about the different ERCs happening in the space and giving feedback and contributing in that way.